So naive Bayes classifier example. In the earlier video, we saw how naive Bayes classifier works. So in naive Bayes classifier, the problem statement is given a given a class, given a data point x, to which class it will belong to, right? So given a data point x, to which class it will belong to, and that question we are asking, right? For that we are computing the probabilities, probability of C given x. So this x data point may have various features like this, features f1, f2 up to fn. So given, so this problem turns to, given these features, what will be the class, right? So that probability we are finding, and that the formula which we derived was, so probability of C given these features is equal to probability of C into probability of f1 given C into probability of f2 given C into probability of f3 given C, so on and so forth, into probability of fn given C. So is equal to probability of C, this probability, into product of I is equal to 1 to n, probability of fi given C. So this is the formula which we'll be using. So now let us try to solve an example using this formula. So here is the example. So we are given the forecast, weather forecast of a day, and we are asked, should we play or not? Should I play or not? That's the question. Should I, probability of playing, right? Whether to, now this play can take two value, play is equal to yes or no. Probability of playing given the weather forecast, right? So probability of playing given the weather forecast is given in terms of outlook, temperature, humidity and windy. Of course, these will take different values. Outlook will take three values like sunny, overcast, rainy. Temperature will take these three values, humidity will take these two values, and windy will be weak or strong. So given these four features, we are asked, should we play or not? So that's the question we are going to solve here. Given the weather forecast of a day, should we play or not? That's the question we'll be solving. So let us say we are given the data of 14 days. So on day 1, the outlook is sunny, the temperature is hot, humidity is high and wind is weak. So on this day, we did not play. We are not allowed to play with this weather conditions. Again, with these weather conditions, we will not play. With these weather conditions, we will play. Likewise, we are given the data of 14 days, and we'll train our classifier, naive Bayes classifier with this data, right? So, and after training our classifier with this data, we'll ask the question to our classifier with unknown features or weather forecast, right? So with that forecast, should we play or not? That question will ask. So now for training the classifier or learning, in the learning phase, what will we compute? We'll compute, see, the main question or the main probability which we'll want to compute is play, probability of playing, yes or no, given the weather conditions, outlook, temperature, humidity and windy, right? So this has three values, this has three values, this has two values, this has two values, right? So we need to compute, for computing this, we saw that we need to compute the probability of outlook given play, probability of temperature given play, probability of humidity given play and probability of wind given play, right? Of course, with the individual values of outlook. For example, outlook is sunny, and for example, this kind of probability we need to compute. Probability of play, yes, given outlook is equal to, let's say sunny, outlook is sunny. So we'll need this probability, right? Because that's precisely the formula of naive Bayes classifier. So we need to compute probability of outlook equal to O and class play is equal to B. This O will take values sunny, overcast, rainy, and this B play will take value yes or no. So we'll need to compute these probability. So how to compute these probabilities? Let us see here. So now outlook is taking 3 values and play is taking 2 values yes or no. Now when the outlook is sunny, how many times when the outlook was sunny, how many times we played and we did not play. So that can be computed from this table. You see, when the outlook is sunny, we did not play here. When the outlook is sunny, we did not play. Now let's see here, when the outlook is sunny, again here we did not play. Now the outlook is sunny here and we played once. Outlook is sunny, we played twice, right? That means we played twice when the outlook is sunny. When the outlook is sunny, we played twice, right? And how many times we did not play when the outlook is sunny? Again, you can see we did not play 3 times. This one, and this one. 3 times we did not play when the outlook is sunny. So we did not play thrice, right? Similarly, when the outlook is overcast, we played 4 times. This can be seen from the table given. When the outlook is rainy, we played 3 times, and here we did not play 0 times, and here we did not play twice. So we played 9 times. 9 times we played, and we did not play 5 times, right? With various outlook conditions, we played 9 times and we did not play 5 times. So what is the probability of, so what I want to compute here, probability of outlook is equal to sunny, outlook is equal to sunny, and let's say play is equal to yes, right? That I want to compute, right? So that is nothing but play is equal to yes is 2 times. So 2 times out of 9. 9 times we played. How many times we played? What is the total yes we have? Total yes we have is 9. Total yes we have is 9. And out of 9 times, the outlook was sunny twice. The outlook was sunny twice. In total 9 yes cases, the sunny outlook was only 2 times. So 2 by 9. Similarly, we played total 9 times. We played total 9 days, and out of those 9 days, only 4 days were overcast, right? So 4 by 9. Again, here you can see out of 9 yes, the outlook was rainy thrice. So this probability is nothing but precisely what is probability of sunny and play is yes. That's what this probability is. So that is nothing but how many times it was yes, and out of those how many times it was sunny. So desired by total. So desired is 9, sunny was desired is 2, sunny was 2 days it was sunny, and 9 days we played, right? Similarly, probability of no. So there are total 5 no's. We did not play on 5 days, and out of those 5 days, 3 days it was sunny weather, right? Sunny outlook. So similarly, we played. We played. We did not play total 5 days, and out of those 5 days, overcast was 0. On no day it was overcast weather, right? Similarly, this one. So that is how we compute the probabilities. So next, we need to compute probability for every feature, probability of temperature given class yes or no, play yes or class means play yes or no, play yes or no, right? So again, temperatures takes 3 value, hot, mild, cool. So we need to compute this probability of hot, and we played, that means yes, probability of hot, we did not play, right? So that means this is temperature and this is class. So we need to compute this also. So by using the same method which we used, this table can be computed again. So this table needs to be computed in the similar fashion, and this table needs to be computed in the similar fashion. Also, we need to compute the probability of class. Class is play. So probability of play. This play is taking 2 values, yes or no. Wise, yes, and no. No. So we will compute the probability of yes and also probability of no. So probability of yes is 9 times we played out of 14. right? So we played 9 days out of 14, and probability no is we did not play on 5 days out of 14. So that's the idea here. So we need to compute this also. So now finally, let's say we are given some unknown forecast, weather forecast, right? So like this, the outlook is sunny, the temperature is cool, humidity is high, and wind is strong. So will we play on that day or not? That's the question. That's the question. We are given some unknown weather forecast, and the question is, will we play on that or not? That's the question. So how can we solve this? So this is nothing but probability of outlook is equal to what is the class? Probability of class probability of play is equal to yes given these weather condition, right? That's what we want to find. Probability of yes given these weather conditions. That's what we want to find. What is that? And then probability of play is equal to no given these weather conditions. Whichever probability is higher, we'll go with that class. That means this on this day we will either play or not. That will be decided by this probability. So here is probability of play is equal to yes. Probability of play is equal to yes with this data with these weather conditions. So probability of so this can be computed like, so probability of this class, that is this one, by using Bayes theorem, naive Bayes classifier. So probability of this class, right, that is this, into probability of sunny. So this is sunny, probability of sunny given class play is equal to yes, because we are going with class yes here, right? So it is we are going with class yes, that's why this is class yes. So then probability of mm, cool, temperature is cool given this class is yes, right? So probability into probability of humidity high, probability of high given class is yes, into probability of this wind is strong given this class yes. So this value, these values we have already computed earlier. So we just need to put in those values here. So what are those values here? We can see from here. Let me show you values here. So here from here we can see, right? So the probability of sunny given class is equal to yes is, we can see from here, probability of sunny given class yes is 2 by 9, right? So this is 2 by 9. So I'll simply put this 2 by 9 here, and then probability of cool, temperature is cool and class is yes, right? So that again can be computed from here. Temperature is cool and class is yes is 3 by 9, right? So I'll put that 3 by 9 here, right? And then 3 by 9 again for this is 3 by 9, you can see from the table. For this is again 3 by 9, and the probability of this class play is equal to yes is 9 by 14, right? So we are playing on 9 days out of 14 days. So this comes out to be 0.0053 if you compute, right? Similarly, for class no, now for probability play is equal to no, this thing we are computing. For this again probability of the probability of sunny given class play is equal to no. This will remain for every term here, right? This will remain, right? Given no, given no, given no, right? Only thing is probably this will change here. Sunny, outlook sunny, temperature cool, humidity high, and wind is strong. So we'll and again we have already computed these values from in these tables here. So you can go get those values from there and put in those values, and you will get this to be 0.0205. So now you can see out of these two probabilities, so this is higher. That means with these given, that means class should be no. That means with given weather conditions we should not play, right? So since probability of class play is equal to yes is less than probability of class play is equal to no for given weather forecast or data point, So we classify the new instance x dash to be no. So new instance is classified to no. That means if I add here, now this was day 15, if I add those conditions here, so this class will be no, right? So day 15, if I add here day 15, so this is x dash, so x dash, right? So that is how we solve the uh, numerical examples on by using naive-Bayes classifier. That's how we use naive-Bayes classifier. So I hope you understood and it will help you. So thank you for watching.